Welcome to the DIY Honda Garage channel. Hello everyone. Today's presentation focuses on the Diagnostic Trouble Code DTC P2122, which indicates an issue with the Accelerator Pedal Position APP Sensor A, specifically relating to the Throttle Position Sensor D circuit, showing low voltage. This problem can significantly affect the vehicle's throttle response, potentially leading to reduced engine performance or even stalling under certain conditions. The Honda Civic models from 2006 to 2011 may experience this issue due to component wear or electrical faults. It's crucial for technicians to properly diagnose this code to ensure safe vehicle operation. We will explore the components involved, the possible causes, symptoms, and detailed troubleshooting steps to identify and fix this issue. The Accelerator Pedal Position APP Sensor A is crucial for interpreting the driver's intentions to accelerate the vehicle. Located at the accelerator pedal assembly, this sensor converts the mechanical movement of the accelerator pedal into an electrical signal. Essentially, it communicates with the Engine Control Module, ECM, or Powertrain Control Module, PCM, to adjust the throttle position based on the driver's input. A low-voltage signal, as indicated by DTC P2122, suggests that the sensor may be malfunctioning, or there could be an electrical issue affecting its performance. Typically, this sensor connects using a 6-pin connector, which facilitates communication with the vehicle's complex electronic systems. Diagnosing this error quickly can help restore the vehicle's performance and maintain a safe driving experience. Diagnosing the P1212 code involves understanding several potential causes behind the low-voltage circuit issue. Firstly, a malfunction in the APP sensor itself could lead to inaccurate voltage readings. This could stem from internal failures within the sensor due to wear and tear over time. Secondly, faulty wiring along the circuit can introduce resistance or intermittent connections, leading to voltage drops that trigger the DTC. Lastly, poor connections at either the APP sensor or the harness, leading to the Engine Control Module, ECM, could also be culprits. It is important to consider these factors during the troubleshooting process to effectively narrow down the root cause of the issue. Understanding the symptoms associated with DTC P2122 is crucial for diagnosing the issue accurately. One of the most prominent symptoms is poor throttle response, where the vehicle may feel sluggish or unresponsive to accelerator input. Additionally, the vehicle may experience stalling, particularly when trying to accelerate from a stop or during deceleration. This can be unsafe in high-traffic situations. The check engine light will typically illuminate, alerting the driver to the DTC stored in the system. Other minor symptoms may include erratic engine behavior at various speeds, which can contribute to an overall unsatisfactory driving experience. Observing these symptoms should prompt an immediate diagnostic evaluation. The initial step in troubleshooting DTC P2122 is to turn the ignition switch to the on position, which energizes the vehicle's electrical systems without starting the engine. In this state, it is crucial to record all freeze data and any onboard snapshot available within the vehicle's diagnostic system. Freeze data provides a snapshot of the vehicle's conditions at the time the DTC was triggered, which is invaluable for accurate diagnosis. Additionally, reviewing general troubleshooting information relevant to the error can guide the technician in addressing the specific issue effectively. This foundational step is vital for setting a solid groundwork for further testing and ensures that the technician has captured all relevant data before proceeding. The next step involves checking the APP sensor A's data using a Honda Diagnostic System, HDS. Technicians will look for voltage levels at the APP sensor to determine if they are around 0.2 volts or less. If the reading is at or below this threshold, it indicates a potential issue needing further investigation. Should the reading be above this level, it typically suggests that the system is functioning correctly at that moment, leading to an intermittent failure scenario. In this case, the technician should consider inspecting for poor connections or loose terminals at both the APP sensor and the engine control module, ECM, or powertrain control module, PCM. This step ensures the sensor's integrity and its electrical connections are thoroughly assessed. In troubleshooting step 3, turn the ignition switch to the lock position to ensure a safe environment when working with electrical components. Next, disconnect the APP sensor's 6-pin connector to facilitate accurate voltage measurements. This disconnection isolates the sensor from the circuit, allowing the technician to obtain correct diagnostic readings without interference. After disconnecting, the technician will prepare to measure voltage across specific terminals of the APP sensor connector, pivotal for evaluating the sensor's operational capabilities. This methodical approach reduces the risk of misdiagnosis and allows for a more focused evaluation of the electrical functions associated with the sensor. After disconnecting the APP sensor, the technician will proceed by turning the ignition switch back to the on position. This step is essential as it re-energizes the system, allowing for a measurement of voltage across the relevant terminals of the APP sensor's 6-pin connector. Specifically, the voltage between terminals number 2 and number 3 must be evaluated. If the voltage reading is approximately 5 volts, it indicates that the system is functioning as intended in this segment. However, if the reading deviates from this expected measurement, it directs the technician to investigate further. Low voltage signals at this step could suggest wiring issues or sensor malfunction, warranting further troubleshooting to ensure accurate diagnostics. In the 5th step of troubleshooting, the ignition switch is turned to the lock position, again to ensure safety when proceeding. Following this, the technician will use the Honda Diagnostic System, HDS, to jump the SCS, Service Check Signal line, a necessary step for engaging diagnostic modes. This is crucial for accessing deeper diagnostic functions and running tests. The next action involves disconnecting the ECM or PCM connector A, specifically the 44-pin connector, to isolate it for further testing. By removing the ECM or PCM from the circuit, technicians can ensure accurate checks for continuity and potential electrical faults that could lead to the P2122 code. This method maintains a systematic approach to isolating components, reducing uncertainty in diagnostics. At this point in the troubleshooting process, the technician checks for continuity between APP sensor terminal number 1 and the vehicle's body ground, an essential step to evaluate electrical integrity. Continuity indicates that an uninterrupted electrical path exists. Therefore, it's crucial to validate if the wire from the APP sensor to the ECU, engine control unit, is intact and free of shorts. This check is often performed using the HDS to ensure accurate readings. If continuity is confirmed, it illustrates that the wire and connections are functioning correctly. However, if there is no continuity detected, this suggests a break in the wire or poor connections that require immediate attention, leading the technician to the next step in the diagnostic process. In the final troubleshooting step, if continuity tests indicate a problem, the technician should connect APP sensor terminal number 1 to the vehicle body ground using a jumper wire. This action helps to establish a direct ground reference for testing purposes. By doing this, the technician can observe whether the system responds appropriately, which should indicate if the APP sensor requires repair or replacement. If the component behaves correctly with the jumper wire in place, it suggests that the issue lies within the wiring or connectors used previously. If unrepaired shorts or other faults are evident, diagnosing further may become necessary. Consistent attention to detail during this step ensures that technicians can accurately ascertain the underlying issues affecting the APP sensor's functionality. After successfully completing repairs concerning DTC P2122, it is essential to verify that all repairs are effective. This involves clearing the Diagnostic Trouble Codes, DTCs, from the system to reset the Engine Control Module, ECM. Following this step, a test drive is crucial to observe the vehicle under real-world conditions. During this drive, technicians must pay close attention to the throttle response and overall engine behavior. If everything operates normally and no new DTCs surface during the drive, the repair can be deemed successful. This verification process ensures that the issue is resolved and confirms that the vehicle is back to optimal running conditions without recurring faults. Preventive maintenance plays an integral role in minimizing the chances of encountering DTC P2122 in the future. Regular inspections of the Accelerator Pedal Position, APP sensor, and its associated wiring should be part of a routine maintenance schedule, ensuring all components remain free from wear. Cleaning electrical connections regularly can prevent poor connectivity, which is often the precursor to low voltage issues. Technicians should also monitor overall vehicle performance, noting any changes in throttle response or engine behavior, as these could signal potential problems before they escalate. By instilling a preventive maintenance culture, vehicle owners can improve longevity and reliability and reduce repair costs across the board. In summary, addressing DTC P2122 requires thorough diagnostics and an understanding of the systems involved. A comprehensive view of the accelerator pedal position, APP, sensor, and its connection to the engine control system is essential. Identifying and repairing the root causes of this issue not only resolves immediate concerns, but also contributes to the overall reliability of the vehicle. As we discussed, implementing preventive measures such as routine inspections and proper maintenance can significantly mitigate future issues related to this code. By taking these proactive steps, technicians and vehicle owners alike can ensure enhanced performance and safety for Honda Civic models from 2006 to 2011. Please like and subscribe to the channel. See you next time.